let me see if I can explain these two guys with a nice little real world example. All right? So again, we know that if I want the number of elements in A union B equals NA plus NB minus N A intersect B. Now there's a word for this. Okay, that's a minus, by the way. There should be a minus, not equals. Minus the number in the intersection. This is for not mutually exclusive events. In other words, two things that can happen simultaneously. Not mutually exclusive. If the number of A union B simply equals the number of elements in A plus the number of elements in B, then the events have to be mutually exclusive. Mutually exclusive. And an event is just a thing that's happening. So, for example, how many ways can I draw a card out of a deck of cards? So how many ways can I draw one card out of a deck of cards and have it be excuse me, either a jack or a king? How many ways to draw jack or a king? So the question is that you got to ask yourself is it mutually exclusive? Is it possible to draw a card and have it be both a jack or a king? Or excuse me, have it be possible to be both a jack and a king? Of course the answer to that is no. So the number of ways to draw a jack or, notice that union, jack or a king, which is exactly the same thing as the number jack union king, because they're mutually exclusive. I'm going to refer to this as ME. Because they're mutually exclusive, it's just the number of ways to draw a jack plus the number of ways to draw a king, affectionately known as 8. Now, how many ways? Let's say, so exactly the same process. We're going to draw a card out of a deck of cards. Ways to draw a jack or a heart. Now the question is, that's supposed to be a heart. Forget it. Wow. The number of ways to draw a jack or a heart. Now we have to ask ourselves, is it possible to draw a card and have it be a jack and a heart? Well, yeah, the jack of hearts is both a jack and a heart. So what we've got is the number of ways to draw a jack union a heart is equal to the number of ways to draw a jack plus the number of ways to draw a heart. Now, there's a problem though, right? Because there are 4 jacks, but one of them is also a heart. So when I go to count hearts, I've counted that element twice. So I have to subtract out a jack and a heart, or a jack intersect heart, which is really the jack intersect heart, which is really just the jack of hearts. So how many jacks are there? There's 4. How many hearts are there? There are 13. Again, the jack of hearts got counted twice, so I subtract out 1. And there are 16 ways to draw either a jack or a heart, almost a third of the deck. All right, cool. Now, this last little piece of information, not much to it. It's called the fundamental, or the multiplicative. I'm going to call it the fundamental because it sounds cooler. The fundamental principle of counting. Principle. And I've never seen a good counting. There's not an elegant way to write this principle. It's nuts. Let's do it with an example. All right. So we got a kid named Billy. Billy's going to dress himself. No. And Billy's got 3 pairs of shoes. So 3 pairs of shoes. Pairs of shoes that can't be intermatched. That just doesn't make any sense. In other words, they have to be as a set. Billy's not crazy. He's just got 3 pairs of shoes. He's got 5 pairs of pants. 5 pairs of pants. And let's just go 6 shirts. how many different outfits are there. Now, a different outfit is simply defined as if I wear the same pants and the same shoes in two outfits, but I change my shirt, that is a different outfit. You see what I mean? I can change two things, I can change one thing. If I change all three, of course, that's going to be distinctly different. All right, if I change nothing, it's the same one. Well, we've all seen this problem. You've seen it on tests and quizzes and stuff all over the place. So that's easy. The number of outfits. How do we do it? Well, there are 3 shoes, there are 5 pairs of pants, and there are 6 shirts. So it appears as though young Billy has 90 outfits. Now, why do I multiply them? Well, because of the fundamental principle of counting. All right? Now, we can also show this, if you think about it. I'm not going to do the whole thing. If you think about it, we can also show this with a tree graph, and you see this in every textbook probably that you've ever seen. What does he do? He selects his shoes first, and there are 3 options. All right? So we got shoe 1, shoe 2, and shoe 3. And then what happens? Well, once he's decided on his shoes, he's got 5 pants that he can choose from. 3, 4, 5. Again, I'm not going to do this for all of them. So this would be P1, P2, P3, P4, and P5, right? And that would come up there 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. Now, I'm going to go off of this one because I give myself the most room. Now, there are 6 shirts. 1, 2, 3, 4, 5, 6. And each one of these would have 6 things pointing off of it. 1, 2, 3, 4, 5, 6, etc. And if you added them all up, I mean, if you think about it, there are 3 ways to make the shirt or the shoe choice. There are, what do we say, 5 ways to make the pants choice. And then there are 6 ways. And look, I mean, you could just see how they work out mathematically by virtue of this tree diagram. You end up with 3 times 5 times 6, which is 90. It's standard issue. You'll hear, how many different meals can you make if there are 5 salad choices, 7 meat choices, and 6 starch choices, whatever. So this exemplifies the fundamental principle of counting. If you really think about it, again, there's just no gentle way to write this. So the fundamental FPC, fundamental principle of counting says, if there are, and I'm not going to write the whole thing out. I'm just going to sort of throw it out here for you. If there are n choices for one selection, right? Or there are n selections for one choice, however you want to write it. There are p choices for another. There are q choices for a third, etc., etc., etc. Now, the most important thing here is that and they are being combined. They are being combined into one unit. In other words, an outfit combined into a single unit. A single unit. It's kind of cool how it fades near the bottom of the page, isn't it? It's also kind of annoying, to be honest with you. Then this implies that the number in the combination, the number in the unit, number of ways to do the unit, is n times p times q, etc., etc. All right. See, it's just an inelegant way to describe it. It's amazing that we haven't come up with a more mathematically friendly way to describe it. All right. Hey, that's it for counting. So hope you enjoyed. We're going to be doing a bunch of it in class tomorrow. And have a good day. We'll see you tomorrow. Bye-bye.